Some extra practice for parametric equations. So here we go. This is just a chance for you to improve things, to figure out what's going on. Got ourselves a circle. We don't know how big it is. This is the starting point and also the terminal point or initial point. And it's going kind of clockwise because x is cosine and y is sine. And we've done this before. So if a equals 2, I say to graph this using the following parameter intervals. Not going to get into this. All right, the radius, I mean, it's up here. All right, so there's the graph of it. I'm not going to graph it again. If it's, 2, then it's 2. If it's 1, so be it. 0 to 2 pi, it starts here, goes around, and comes back here. So what happens if you just make it from 0 to pi over 2? It would just be in quadrant 1. 0 to pi. And I recommend you put all these into your calculator. Just be in quadrant 1 and quadrant 2. Nearly drew the wrong 2. Now how about 2 pi to 4 pi? No, that actually will do the exact same thing as 0 to 2 pi. That's just once around. And if it goes from 0 to 4 pi, that's twice around. Hopefully that describes the role of the length of the parameter interval. All right, so now let's go with a equals 3. And they want us to graph it. Well, I've already graphed it, so I'm not going to graph it again. I say use these intervals. All right. What's the initial point and terminal point in each case? Well, the first and I'm going to go starting point. Second coordinate is the terminal point. Now I'm not going to go around and label all these IP, SP, IP, SP. Play with it in your calculator, see what happens. It's really not a big deal. All right. Make sure you put arrows on your graph so you know where it starts, where it ends. Okay, so now we have something slightly different. Let's go with 0 to 2 pi. So cosine of 0, sine of 0, you get 2, 0, it starts here. Now we put in pi over 2, it's negative pi over 2. So we're going backwards. Still gets us to 0. Negative pi over 2 gets us to negative 1. So this would start here. And go this way. Let's check out pi, see if that gets us here. Yeah, we know it does. Let's check out 3 pi over 2. So cosine of negative 3 pi over 2 is the same as cosine of 3 pi over 2 because it is an even function. That would be 0. And then negative 3 pi over 2 would be positive 2 right up there. So positive 1 times 2 is up there. So that is 0 to 2 pi. All right. Pi to 3 pi looks the same, but it starts in a different spot. Now it actually starts here. So that's, oops, pi to 3 pi. Pi over 2 to 3 pi over 2 would start here and stop here. So it's just a chance for you to play and, figure things out. It's not a big deal. Let's see what else we got in store. All right, now we got an ellipse. X equals a cosine of t, y equals b sine of t, a equals 2, yada, yada, yada. Starts here, up it goes, around it comes. Goes in this direction. All right, now I'm not going to repeat changing b to 4, 5, and 6 because we know it would just change the y-axis, make it taller, all that stuff. Now, what if we had 3 and 4? Well, just write this in. What if we had 3 and 4? Same deal. And if they change a, this would change to 5, 6, 7. That's it. Really nothing earth-shattering. So how do you identify the axis that contains the major axis of the ellipse? Well, the bigger number is going to be the major axis. And the smaller number will be the smaller axis, the minor axis. All right. I'm not graphing this again because you've already seen it up above. This would graph in Q1. This would graph in Q1 and Q2. This would graph in Q1, Q2, Q3. And this would go around twice. Now we get back to the kind of weird little starts at one spot, ends up in another. So let's see what's going on. 5 and 2, so this would pi to 3 pi. And this would be the pi to 3 pi case. This would still have the same direction. Football one here. But it would start all the way over here at pi over 2. Since we have negative, well, I think things would go backwards, wouldn't they? Yeah, they are going backwards. I was nervous that I messed something up there. So they are going backwards. And pi over 2 would actually start over here. And 3 pi over 2 would actually end over here. That doesn't seem right. Oh. So I have these backwards. Oh, cool, I can be lazy. That's so lazy. And this would be pi to 3 pi. Starting point and terminal point. The bottom line is I want you playing with these. I don't want you just doing the standard student thing where you say, yeah, that makes sense. And you don't know what the hell you're talking about. So happy mathing.